thank you for your patience. Hi, Don. Hi, Anton. Hi, everybody.
Hello, hello.
All right.
Good evening, everybody.
Good evening,
Now,
Don. Good morning.
Good morning.
Thank you for joining us, and thanks to everyone who decided to join us and stuck with us through our technical difficulties this morning. It looks like everything is finally sorted out, so we can make a start. So just to recap again, this is the essentially the capstone salon for the Scientific Freedom Book Club, Don's book, and he joins us here today as the author to discuss some of the ideas that we discussed very extensively in the book club. We've got a great mixed audience. We've got a great mixed audience here today of people who participated throughout the whole book club, people who sort of dropped in, and also people who are just interested in the ideas around scientific freedom and how to organize it and what sorts of benefits it can give. And so I thought a good place to start would be, Don, asking you what freedom means to the practicing scientist. What is freedom in the context of science?
Well, I dare say if you asked Albert Einstein what he thought freedom was, he wouldn't know what you meant, and neither would any of the other scientists who worked certainly in Britain, I think also in the States before 1970. They assumed that it would be there, and they did not consider that what they were doing was particularly free, because they thought, well, that was what scientists did. And so they looked at a problem and they decided what they wanted to do, and then they did it. I mean, it's as simple as that. There was no bureaucracy then. Well, there was, of course. You would never eliminate bureaucracy, but once you were appointed, once an academic got an appointment, then that was difficult. As difficult then as it is now. There were fewer academics, of course, and I'm just getting rid of something. There were fewer academics then, and so well, I had nothing further to add. It was part of the normal way of doing things. They didn't realize they were free.
So in your opinion, then, what changed? What does the absence of freedom look like today for the practicing scientist?
Well, that all changed when politicians decided to increase the number of universities and the number of academics in the universities. It's approaching tenfold increase in the number of academics since before about 1970. And so then the previous laissez-faire attitude to research, where anyone did anything they wanted, provided their requirements were modest. There was still peer review, by the way, before 1970, but it was when people needed special pieces of equipment, like a Van de Graaff generator or something like that, and they then had to write a proposal, and that was assessed and decisions were made. But now there were so many universities that there cannot be freedom. And so therefore, the funding agencies the world over have had to find a way of limiting the number of proposals they approve. And they have, and it's remarkable that they have chosen, always, academics are noted for their individuality. They have, but every country has more or less ended up with the same arrangements, and that is you write, if you think you want an idea if you have an idea for research, you write it up. You have to write it up. You have to think of everything that might happen in the 2 or 3 years for which you apply for funding, and you then send it to your university looks at it first. They then see whether they will forward it to the funding agency. The funding agency then sends it out to a few of your peers, which means your closest competitors, and most of them operate anonymously. So it's a ridiculous system, really. But everyone is totally wedded to it. You cannot criticize peer review today. Everything, unless what you say has peer review approval, it is discounted.
So what in your opinion have been the consequences of this let's say to use a particularly insightful word, subjugation of scientific freedom to bureaucracy? What are the effects of that in the academy and beyond?
Well, it means that research is increasingly predictable. You have to be able to say what you're going to do, and the funding agencies they all have priorities. And so first of all, I've said when a scientist has an idea, he writes it up. That's not quite correct. When a scientist had an idea, he must check whether his idea fits within the funding agency's priorities. And if it doesn't, he adjusts it and so that it does, so it can be considered. It's a crazy way of doing things. So that's what, you could not think of a more deterministic system if you tried. So everything's so predictable. We're working towards a predictable future.
Which of course, as we know from the structure of scientific revolutions, isn't where novel science comes from, isn't what really advances us, right?
No, I mean, novel science, the major advances science, I mean, that is, has always been a very rare event. We're talking about less than 1% of all scientists. Maybe the present methods of allocating funds are fine if you know precisely what you want to do, and you know precisely where you want to go. Nations can have priorities and strategies, and your ideas must fit within those bounds if they are to be considered. Funding rates, by the way, are around about 20%. That means 80% of them get rejected, which means that a lot of excellent proposals are lost. It's a very, very inefficient system.
One of the things we spoke about in our call in preparation for this meeting was the effect that this has on young people entering the academy and wishing to be scientists, and the sort of the disparity between what a young person imagines or dreams of becoming when they think of being a scientist versus the reality. Do you think that also has a chilling or constraining effect when people who could do radical work have that spirit squashed out of them?
Oh, of course. I mean, before about 1970, I mean, I've written this and I mentioned this in the book. The great scientists, I mean, many of them, particularly the theoreticians, were in their 20s. Well, the National Institutes of Health has, in the US, has estimated the age at which a PI first gets support, and it's currently 42 or 43. That's the youngest. And I mean, almost every one of the great scientists had made their discoveries well before they were 42.
So do you suppose that's a function of youth or a function of the change in structure of how the academy works? Because previously, as you said, there were fewer academics, which meant proportionally more scientists, more young people could become, full faculty and have that freedom much earlier. Do you think that that's what's happening? That we just have not enough slots at the top?
Oh, well, it would have to be. There, I say, almost 10 times as many academics now as there were before 1970. Almost 10 times. It's a huge increase. So young people particularly suffer, and that's a great tragedy. If a postdoc now has to find a group in which to attach himself, he cannot propose an experiment to a funding agency. You have to be a tenured academic, more or less. So you have to find someone that you can attach your coattails to, and then as we all know, your vision is then qualified to be the same as your group's vision.
Mm-hmm. This is
So it's very sad.
this is something similar to something that David Deutsch wrote in his ideas around also the knowledge creation and scientific progress, where he believes that we're caught in this idea of new knowledge needing justification for its creation. And I wonder if that isn't in some way an expression of that. That's justification right. from some higher power, whether it's a funding agency or whether it's an established group when you're a postdoc, which is clearly not a way to do things, because in our most productive phases historically, that's not the way things were done. People went off and did things. And the other thing that I'd like to add is, you've mentioned, several times now that there are 10 times as many academics, but it certainly doesn't seem like there's 10 times as much scientific production. Certainly not valuable production, despite the increased volume of publishing. And the thing that I always get stuck on is, we have these mechanisms of peer review, which, as you say, were very effective in the past, because you could be confident that, for example, if a paper was endorsed by the physics community at large, that the results of that paper would be sound, or the degree to which it was sound would be well understood. Whereas today, if you're at a conference in one of these very large fields, and I've been a reviewer in for example, machine learning or computer vision conferences, you're faced with thousands or hundreds of papers. No reviewer can possibly give a fair review to each of these. And I wonder at the extent to which this introduction of scale has broken down many of the systems that actually made the previous smaller academy functional.
Well, yes, I mean, nowadays, I'd say you write a proposal, and that proposal is treated as if it were a completed work.
Yes.
That is then assessed. There are two types of peer review. You've alluded to the system that journals use, and then there's the system that funding agencies use, and they're quite different. If you fail to get published, if your favorite journal turns down your paper, you can always send it to another journal. But funding agencies have strict rules about that. They take a very dim view of people sending the same proposal to lots of funding agencies. So you have to hit it on the head straight away, hit the nail on the head immediately. It's a crazy, as I say, it's not a sensible situation, but it works. It works most of the time, you see, because most scientists, are quite happy with these arrangements. It's only the very rare ones where it's maximally wrong.
Do you suppose that it really is that a rare or proportionally few scientists would pursue radical ideas, or do you suppose that people just tend to get molded more by the system that they're in? Is it something endogenous to people, or something forced upon them, or what's your position on that? Do you suppose only 1 in 1,000 could be a member of the Planck Club?
Well, yes, but that it cannot be determined by peer review. Who they are. Yes. They must be able to be self-identifiable. They must be able to I mean, they didn't have to do that before 1970. They just went ahead and did it. But now what I'm proposing is they write a proposal, and we look at it. That is, we meet them. Those who we think are raising an interesting thought, an interesting idea, we talk to them. And mutual trust, we have to build up mutual trust, because unless there's mutual trust, they won't tell us anything. They will tell us what we want to hear.
Let's talk a little bit now about your proposal for an alternative model here, venture research, which you've had experience with implementing in practice, as opposed to many of the things that we've talked about in the book club, and especially which have remained more theoretical ideas. I mean, we're yet to put some of these things into practice. And I'd like to speak to your experiences there. So what does it take, in your opinion, to select a member of the new Planck Club? How does that look? So you've said about establishing trust, but what does that look like in practice? And maybe with reference to some of the venture research proposals that were successful, what did some of these people look like when they approached you, or you approached them?
Well, it's difficult to say, because it's the ones we've picked have been picked, but they've been selected. But when they first met us, we had no idea what they were talking about. we didn't be peer review. The language is common. All the buzzwords and slang words are all known, well known to them. But we had none of that. We were just one or two people. There's usually a physicist and a chemist, maybe, and we may be talking to a geologist or something. We just had to first of all talk to them and get them talking to us about anything. Doesn't matter, sport or music or the theater or something like that. And you slowly build up, and you can tell. I mean, you can tell if you've built up trust by the way people are open, and it may take a meeting or two before that happens. You can tell how they answer your questions, whether they're guarded, whether they're careful about what they say. When they're not careful about what they say what they really want to do. And so I don't know. I don't think there's an exact prescription of how you describe that. But but the scientists are comfortable with each other. The scientist, the proposer, and the assessor, and you try to build up a relationship with them, whether or not they will be funded. It doesn't matter, you don't know whether they will be funded. You don't know whether they will be, you see, there's very little understood today. There's so many fields we know very little about. I hardly need to say because I mentioned in the book, we look for people who have identified an intellectual green field site, and they so we try to establish that they are a good scientist, that they're good scientists, that they will be not easily put off, and if they're going into an intellectually greenfield site where no one else has ever been, they can't fail but make major discoveries. They can't fail. This is why I keep on saying that venture research is very low risk. But there are very few of them, you see. At UCL, we've only found one in 10 years. One in 10 years. So, but he identified, he persuaded us that he was worth backing, and we did. And since that time, please.
No, please go ahead, Don.
No, I more or less come to the end of what I was pontificating about.
I see Jason with a hand raised. Maybe you'd like to jump in, Jason, with a question?
Sure. Yeah, I have lots of questions, but I'll ask one at a time so other people get a chance, and maybe I'll jump back in the queue every once in a while. One thing on my mind right now is I have an idea of how this is all breaking down in the sort of like big government agencies like NIH, NSF, and sort of whatever the equivalent is in the UK, et cetera. What about some of the private foundations, like the Simons Foundation has like hundreds of millions of dollars a year for physics and math. There's other, like, why aren't they kind of filling this gap? As they seem to have plenty of budget compared to what your program that you've outlined, which is very modest. What are they doing wrong, or why aren't they kind of coming in and filling this hole?
It's a very good question. I don't know. I suppose human beings are always convinced that they are right. Always convinced that their approach to the world is the only approach there is. And they have the money, and so they can do what they want. And so that's what they do. So they have, the Simons Foundation is an excellent organization, and there are quite a few of them like that. So there's no shortage of that, and particularly in the States, as you well know, there's no shortage of that. But I don't know why that. I think the opposition is to peer review. I don't know whether the Simons Foundation, for example, uses peer review at all. But if they do, they will, so to speak, have a blank out certain proposals. As there will be no go areas if they do. to answer your question, I don't know why they don't do it like this. I really don't know, because they wouldn't have to do all their work like this. They would only have to do a very small proportion of it. They would have to appoint someone, someone like Anton, say, to look after it.
Maybe someday. Maybe someday. Anna, Anna, I had you next.
Thank you so much, and thank you so much, Don, for the incredible points made so far. I come from the humanities, and I every time I think about this, there are so many parallels that I see between censoring artists and trying to diminish the creativity of artistic output. And you start your book quoting Szent-György's very Nietzschean differentiation between the Apollonian and the Dionysian scientist, the methodical versus the creative or unexpected, even though we know that most scientists and most thinkers are somewhere in between, right? They have phases, they have a kind of combination of the two. But it also makes me think about, the woes in creative writing in the US, for instance. There's now an AI that can detect if a prose was written by somebody who studied creative writing at a university in the US, because it will just ruin your syntax forever. And if you have a hard time finding a good novel written after the year 2000, there's a reason they are becoming increasingly schematic and predictable. And that's bad, right? You want a new Dostoevsky, you want a new Virginia Woolf. I mean, imagine sending Virginia Woolf to a Northwestern to tweak her syntax. Probably she would have been a little bit, unhappy with that. But this also makes me think, can there be novel solutions that borrow from how artists break out from, the confines of censorship? Can there be a salon des refusés of scientists? Is there going to be a parallel universe while the bureaucrats are not looking, just kind of being built out behind the scenes? And if so, how can we join?
Yeah. Well, I don't know if there was a question there. Did you have a question?
Yeah, so the question is there an underground, artistic revolution just in science that may have been happening, just in the past couple of months that we should know about?
A revolution in science? Well,
and scientific underground, I think, is what Anna is asking about.
Where are the punks is my question.
Where
are the punks?
Well, scientists come in all sorts of shapes and sizes, but it's their ideas that are trampled upon by peer review. There is enormous potential in science, absolutely enormous. As I say, I mentioned that we almost understand nothing about how the universe works. This consciousness, we only have the very dimmest approach to understanding how that works. But we've talked about the rarity of Planck Club scientists, but every serious scientist, I believe, at some time in his or her career, will come across something that they'll say, "That's funny, that shouldn't happen," and they will want to explore it, but they won't be allowed to do it, because they will, unless that vision fits into the vision of the funding agencies, then they're hiding to nothing. They will not get supported. And it will, by the way, spontaneity has been lost. It takes more than a year to go through this. In the olden days, you could just do it. And now it takes more than a year before you get an answer, or it can take up to more than a year before you get an answer.
I think Anna makes a very excellent point as well, in that in the past, before the sort of professionalization of science under people like Vannevar Bush, this wasn't such a great distinction between what an artist and what a scientist did in society. Ultimately, they were both seen as creative pursuits. And somehow, since the professionalization of scientists, and you mentioned this is occurring sometime in the 70s, Don, science has stopped being regarded by society in general as a creative pursuit of the same order. And I wonder if that isn't contributing to some of the problems that we see. And we've organized it almost as an industrial process when that's not where the benefits come from.
I suppose it depends on the attitude to universities, and I've tried to think about this, what happened before 1970, but what people's attitude to universities was. But they knew that that there would be a steady trickle of amazing discoveries coming from this organization, and they were worth backing, therefore. Because, you know, MRI and lasers and et cetera, kept popping up. Transistors kept popping up. This steady trickle of spectacular new discoveries emerged from this institution called the university. So therefore, it was worth backing. It was worth supporting. But nowadays, that is not happening. So people's attitude to universities will be, well, what are they for? What do they do? It's a very serious question.
Definitely, and especially in places like the United States, where actually going to university incurs an enormous financial burden. People really are asking that question in a very genuine and a very serious way. It has enormous implications for many people's lives.
Well, we haven't even discussed that. You're right.
Matthias, you have your hand up.
Yeah, so I too am very interested in this topic and could ask a lot of questions, but since we are in this sort of headspace of comparing art with science, I thought I would add sort of perhaps an even stronger point here. So as I think Anna and Anton already noted, right, there seems to be this similarity between the arts and the sciences. They're both these creative pursuits. People are working on these obscure things. You know, it sort of takes a while for them to be appreciated. And yet one thing that is kind of interesting is that the temperament that artists and scientists have when it comes to funding is rather different, right? So artists on the whole, you know, there is sort of government funding for art, but artists on the whole have found all these other ways of kind of trying to sort of fund their work. And it seems to be the case that scientists in general basically expect these sort of large bureaucracies to take care of their funding. And there is very little thought that is kind of going into other directions. So to kind of ask provocatively, right, should basically scientists be more willing to sort of explore other possibilities of funding their work, whether that is self-funding, seeking patrons, all these other things that Anna mentioned? How do you sort of think about that?
Scientists should not give up their ideas. You know, the real Planck Club scientists must persevere. You mentioned that, you know, art and science, if you're a historian, say, and you write about history, then there's no way of proving that your view of the world is better than anyone else's. There's absolutely no way at all. And so even though you're a first-class historian, your view of the world is depending on your writing ability and all sorts of things. But if you're a scientist, scientists are all in communication with nature. They all, sooner or later, have to do an experiment or persuade someone else to do an experiment. And then when that experiment is done, if it disagrees with what they say, it doesn't mean that they were right, because, you know, the universe is infinitely complex, but it's the best that can be done at the time. But there is this independent way of looking at the results of science, which is demonstrable. You know, and this is what Einstein did, for example. You know, he said that the perihelion of Mercury would advance by, you know, 37 arc seconds per century, and it was proved to be right. And so therefore, it doesn't mean that Einstein's theory of relativity is complete. It means that it's the best that could be done for the time, but it survived all the tests we can give it. Now, that does not apply in the arts. So scientists never give up their unique view of the world. They should never try and, I mean, that's what they're forced to do now. You know, they're forced to do that. But the potential of science is enormous. And we don't know what it will have. What, you know, I bought a book in 1960, which was written by three distinguished scientists from Caltech. They didn't mention the word computer once. You know, it wasn't mentioned even. It's just crazy, you see, that to try, and these are three very well-informed people.
Brendan, I have you up next.
Yeah, I'm thinking a bit about the incentives of what leads to the kind of bureaucracy of how we distribute funding. And to some degree, I think there's a CYA going on where if, you know, you're allowed to give out money and you give it to somebody who looks a little bit like a crank, and then 10 years go by and they don't do anything successful with it, you've just spent the government's money or the people's money on some bad thing, and you look like an idiot. And to some degree, you need to be defended from that accountability in order to take those risks. But what is the way in which we can convince the public to not go so hard on the people who are giving out money when they give it to things that look crazy? Because ultimately, it seems like that's why we end up taking these kind of mediocre bets consistently, is that nobody wants to be on the line as being the one who approved funding for something that wasn't obviously valuable.
Well, I mentioned the intellectual greenfield site. If a scientist has identified in an important field of science, like say Ken Seddon, you know, I mentioned him in the book, who observed that almost all science was connected with molecular interactions, and so he therefore wanted to look at the way science would look in if all interactions between chemical species were moderated in an ionic liquid, in an ionic environment, because that these had there are millions of them, or even more, billions. So if you've identified a greenfield site that no one has explored, if the area is important, then there's no risk. You're not, and this is the approach we took in venture research. We had 10,000 people. I mean, most of them were, you know, some of them were proposing the most bizarre things. But I'm willing to be judged on what we did. We didn't once waste any of BP's money, so to speak, because they were all serious people. And I took care that to involve, for example, BP managing directors in all our meetings. We had the chairman of BP come down to our meetings, our annual meetings. And I was petrified when the chairman said, "I want to come to your meeting tomorrow." And I thought he would just come for 2 minutes. But he came at 11 o'clock and he sat next to me, and we stopped at 1 o'clock, and he stayed for lunch. And he was wandering around talking to people because he recognized them as exceptional people. And you can tell by talking to such people, they are truly, and they're inspirational. And this is why I don't understand why the Simons Foundation, for example, don't use this method. They wouldn't need to do it all, 100% of what they do, but only a proportion would need to be of this type.
Dave, I have you up next. Before you go, if people would like to ask a question,
by the way, have I answered your question?
Yes, thank you. Okay,
sorry.
No problem, Don. I was saying if people would like to ask a question, please use the hands tool. We'll queue you up. This is mainly to prevent anarchy in the video call. I know it kind of feels like being called on by teacher, but it's what we have to deal with until the technology improves considerably. Dave, you're up.
Hi, Don. I really just want to say my thanks for writing the book. It helped me focus a lot of my thoughts in this area, and I really appreciate it. It's great to see someone actually do something, not just pontificate, but actually go out there and practice it. I guess my question is, with regards to these intellectual green sites, is this something that's coming from an innate character in these people, or is it a failure of education on our part? Like, why isn't all of science focused around training people to look for these things? Why are we stuck in this mode of very incremental things? Why aren't we training people to look for new fields to open up?
Well, the Japanese have a saying: when everything looks like a nail, all you have is a hammer. I mean, the fault is not in the fault is not with scientists. It's the way society has organized itself to control the number of the vast increase in the number of academics, as I've mentioned several times, and that method has resulted in controls on what people are allowed to think. So for the first time since the Renaissance, that's 300-400 years, the limits of what scientists, what academics are allowed to think, because academics won most of the members of the Planck Club were academics who were not industrialists. So it really is a crazy way of going about it, but it comes back from the top. It's top down that conditions the way scientists are obliged to think. They are obliged to be not adventurous. Is that what you meant? Is that this?
Yeah, but I guess we're talking about disagreeable people to begin with. If you're going to go invent a new theory, you inherently don't agree with what's going on. And I guess where's the gap there? Why aren't these disagreeable people getting their ideas propagated? You read biographies of these people, and they're arrogant, and they refuse to listen to other people, and they just want to take their ideas all the way to the finish line. And why aren't we getting more of that? I mean, we so desperately need it. You can't go a day without seeing a headline of someone claiming that the world is going to end one way or another. But the total inability to enable and empower these people who we know are there. It's not like I don't think that any of the people now are any less smart than any of these other people. I don't think there's been a decrease in intelligence.
Well, but you see, before 1970, there was not this exclusive top-down. There was no top-down imposition of what people are allowed to think. I mean, I used to work in the cabinet office, and I've got all sorts of white papers. The scientists in 1960 were very, very penetrating. They said that you cannot control scientists from the center. You cannot do it, they said. But that's been forgotten. You have to allow scientists to be free to express their ideas, and to there will be cranks, but there are ways of dealing with cranks. You ask them, okay, you say the thermodynamics is rubbish, so what do you want to do next? What is your next step? What do you want to do? Well, that usually silences them. You never hear from them again.
That's a very good judo move. Just, okay, we agree, but what do you want to do is a very powerful question a lot of the time.
That's right.
Jason, go ahead, Don. Jason, I have your hand up next.
Yeah, sure. So correct me if I'm wrong. So my understanding is that before 1970 or earlier, when we were in a different mode, I guess scientists just didn't have to apply for grants all the time because they got some basic salary plus, I don't know, lab budget just from the university.
Yes,
and so I'm wondering, what were you say it changed around 1970. Like, what were the steps? Like, what specifically was changed, at a mechanical sort of level? And like, what was the rationale for that at the time? Like, why did people think that they needed to change the system?
Well, because politicians always want to do something, the world over, and so what they did, they decided that in Britain, that it was decided that we need more graduates, so therefore we need more students, so we need more universities, and so it was a top-down decision to change this. Top down. It wasn't the academics who decided that we need to have more academics. It was politicians who decided we need more academics. So this is imposed on the academic structure. And it was decided we would use peer review, the same system that is used to consider publications. We will treat every proposal as if it were a completed work, and then assess that, and then peer review will pick the best of those. And you have to, when you write a proposal, you have to provide a convincing argument of why your proposal will be the best there is. Well, I mean, Einstein,
was it tied? Was it tied to this increase? I'm wondering, was it tied specifically to the increase in government funding? I know in the US, there wasn't an enormous amount of federal funding until the 50s or 60s. Is that what made the difference, that when the government came in, they were like, oh, well, now we need a process?
Well, governments provide the funding to universities. Well, they do in Britain anyway. I know that in the States, roughly half of universities are private, but they tend to use the same approach to life as the publicly funded ones, and so do all the philanthropists. Tend to use peer review as well. They will not risk their money on as we do in venture research on a hunch that someone will do something great. We don't know what it is, but they will do something great.
Just wondering why the old system went away, like why it couldn't scale up. I mean, it seems like, sure, okay, so you have a lot of universities, but why couldn't all the new universities that we're creating, if we want to scale up the system, why couldn't they just all keep functioning the way universities used to function, where people don't have to apply for grants all the time?
Well, that is possible. There was a paper about a couple of years ago, and I wrote to the guy from in a Danish university. I haven't got it. I can't think of it offhand, but they proposed that governments take their budget, whatever they've determined would be their budget to fund research, and everybody then got, and that was divided equally between all the number of contributing parts, and it was workable. They produced a serious argument that it was workable, and that and then you would do away with all the bureaucracy, and you would just, scientists would sink or swim then. So it is possible, but I don't think it will ever happen, actually, because it's too big a change. The change imposed in 1970 became gradual. It was gradually imposed from the top to increase the number of universities, to increase the number of academics, because that was thought the way of increasing. Sorry?
Did the demand for funding start like rapidly outstripping the supply of funding at some point? Is that why we had to go to like more of a grant application system?
If you increase the number of academics, then you increase the number of proposals you get. And so they had to find ways of limiting the number of people that could be supported, and doing that in a fair way. And so they used peer review to do that. They didn't. It's not based on meetings or assessments, but on peer review and priorities. Funding agencies had priorities, and they would only support research in certain fields. And so if you run a funding agency, it's quite complicated, deciding how you will allocate funding between, say, agriculture and zoology. These are completely dissimilar subjects, but that's what universities have to do nowadays, and that's been imposed on them. It didn't arise naturally. It doesn't arise naturally. But as I mentioned, there are proposals there have been proposals for doing it completely differently, but they've been ignored by and large.
I'd actually like to raise a question that follows on in this theme. And Don, this is something we spoke briefly about yesterday, where a lot of what we've been discussing here about the organization of the academy and scientific production rests on the allocation of funding. And one of the things that I often like to say is mathematics is free. It's lying around in the street for anybody who wants it to pick it up and do it. So given that a lot of the problems we've sort of covered, and a lot of the things that are covered in your book rests on this foundation of the idea that science needs this funding to progress, do you think it's possible to perhaps find directions, or sort of especially radical greenfield directions, that perhaps require far less funding than what something like a university typically requires, or the sort of the usual department in the academy requires to function? Could we sidestep this issue by just looking for cheap things?
Well, that's what I do. That's what we do in venture research. But greenfield sites are not, cannot be identified in advance. We don't know what they are. An individual scientist determines what they are. They determine their thoughts and their ideas, and their vision have identified an area which has not been explored at all. No one has ever looked at it. And so therefore, if they can demonstrate that they're serious scientists, then it is well worth backing them, because almost certainly they will do something important. Because as I say, they're going into an intellectually greenfield site. They're good scientists. They can hardly fail to make discoveries, but you can't inflict that from the top. It's not a top-down thing. We don't know what the intellectual greenfield sites are. We don't know what they are.
Absolutely, absolutely, and no disagreement. But it's, for example, and as things like computing costs decrease, and as access to sort of the foundational resources necessary to receive an education in something like mathematics become more widespread, those are things that, regardless of how radical your idea might be in that field, would require far less capital outlay than for example, what we think about as current work in chemistry or biology. And I just wonder about that.
Well,
I wonder about that.
Venture research is almost free. I mean, that is the problem. Because academics tend to view cost as an asset. And they're not going to be impressed if the university's annual spend on venture research is close to zero, which it must be. It must be if venture research works properly, because most universities in most years will not have a venture researcher. But it's an exciting prospect of looking at people, and you're attempting to pick, the future Nobel Prize winners, say, for example.
Sorry, go ahead, Don.
Just like every other people, they tend to see value in cost, and so it's the big bang projects that grab the headlines. You won't grab many headlines by saying, so and so wants to look at ionic liquids, and no one knows whether it's going to be valuable or not. That will not grab them. But back to the old days, when people used to mainly back universities because the steady trickle of great discoveries came from them. And they said, oh, that, and so therefore it's very well worth supporting. But now their ideas may be changing, and the way that the universities are changing too. It's very sad, really.
I think that's a great insight, which I'm going to definitely use, that in the academy, cost is often mistaken for value now. I think that's very concise. As a thing, I tend to think that the academy has evolved into this machine that is now capable of absorbing arbitrary amounts of capital without any marginal product from that. It can simply absorb any amount of money you care to throw in it without actually causing it to accelerate whatsoever. I think we're back to. Go ahead.
But if every scientist getting funded had to identify something that had never been done before, that may change things, wouldn't it? And if you're a scientist, by the way, why should you want to do things where you have competition? You want to avoid competition. You want to be, get in there and do something that no one has ever thought about doing. This is what Einstein and Planck and Rutherford and Dirac and all the other scientists and Towns, etc., etc., etc.
Dyson is another fantastic example. Matthias, you had a question.
Yeah. So on this note, more or less, right? So with all proposals that propose that sort of government scientific funding moves away from this whole sort of committee plus peer review model towards a model where there is perhaps like an empowered sort of allocator of funds that all of these proposals kind of come to him, and then that person makes the decisions. My impression is that governments are often reluctant to move towards such a model simply because it's sort of in the nature of government that it kind of doesn't like to entrust power to opinionated individuals. But on a kind of objective side, when you come to when you think about like who are the people that should make these decisions about which scientists get the funding, what sorts of people should we be looking for? Who is kind of the right person to be looking at this and making that decision, and what should they be looking for in turn?
Well, you're asking me to decide, who are the best peer reviewers. I don't believe in peer review. It's as good as any system for determining which research should be done, but at the margin where great discoveries are made, it is maximally wrong. It does not work at all. And what I'm trying to do is to persuade them that they should admit to politicians that peer review has a serious flaw, and that is what academics are most reluctant to do, because they've always assured politicians that peer review is infallible. It does not make mistakes. But here we are saying, but for a small proportion of scientists, it cannot do other than make mistakes. And that's the problem that we've got in trying to change the way people do support research. They must admit they were wrong in saying that peer review is infallible. No one's infallible, of course, as we know very well.
Timothy.
I answered your question. I'm not clear.
Yeah, I think it was kind of in the spirit of it, but I mean given this sort of infallibility, right? At the end of the day, somebody still needs to make the decisions, and again, how does one kind of approach sort of squaring that paradox?
Yes, our decision is: has the scientist identified a greenfield site, an intellectually greenfield site? Is he a good scientist? And these are all questions you can answer, that can be answered. And is he worth backing? Those three questions. But it's the intellectual greenfield site that no one else has ever, it's a virgin field that no one has ever entered into.
And how do you, for example, think about whether somebody is a good scientist, say? Well,
by the way they ask questions, by the way they look at the world. Most people are scientific in their approach. I mean, not only trained scientists, of course, but most people, there's a disciplined way of thinking. They have a strong discipline of thinking, and they are always looking to test their ideas in ways which I've mentioned before. It is unique to science. If you propose an experiment and the experiment does not prove you right, then you are definitely wrong. That theory is completely out. But the converse isn't true. If the experiment agrees with what you predict, then it means that that's the best can be at the time for the time being, because say universe is infinitely complex, and so the best a scientist can do is a theory that survives experiment.
I do, and I brought this up with you as well yesterday, Don, but I do wonder if we can't be seeding more potential future members of the Planck Club if we just threw younger people into real scientific work earlier. I know that you don't quite agree with me on this, but I'd love to hear your opinion on this again.
You mean throw them into what sort of scientific work?
Well, so this is again taking a cue from history, where the way that new scientists were created was almost through a system of apprenticeship, and you could start that very early. And many, especially 19th century mathematicians and other scientists started almost what we would consider to be right out of high school. And I wonder if we can't adopt that model again. Simply take teenagers, 17, 18-year-olds, and put them to doing some small piece of useful work in real scientific production, and create more future possible members of the Planck Club by simply exposing more young people to what real scientific work looks like.
Well, it's a thought, but as I mentioned to you yesterday, you've got to be able to know what is known, and that takes time. You've got to serve your time, so to speak, you know, and that takes 10 years or more, and you have 10 years of doing experiments. That's the way science used to be done. You know, when I became a scientist, the only thing that bothered me is, you know, what should I do next, and not which funding agency should I apply to, and does it fit their priorities? That never entered into my thoughts at all. So it's complicated. That's what you have to say. It is complicated, and you can't expect a teenager, say, to know what is known, and to know to be able to embrace everything that's happened. You've got to have a pretty skilled idea of what has been done, and that takes a time. That takes decades, maybe 2, before you really know that what you want to do is original.
I think that's quite pointed and a very interesting insight to integrate into my position there. Tim, you've got your hand up.
Yeah, thanks, Don. So before we kind of are able to tear down the current structure and move into this new kind of research funding that you're talking about, what do you recommend?
We don't want to tear down the current structure. We don't want to do that.
Not
we want
restructure, I should have said.
We want to add another dimension to the current methods of selecting research. And this, as I say, should be based in the universities. The universities that know what their people are doing, and they appoint 1 or 2 people, usually, but perhaps senior people, to consider proposals, unique proposals that would not get supported from the present systems, and as I say, to appoint the odd person in 10 years who doesn't fit in with this. But you've got to examine quite a large number of people. But we do not want to wreck the present way of doing things. I mean, that's had a huge successes. I mean, look at COVID, for example. I mean, it really works. So when you know what you want to do and what you want to and when you want to do it, then it's fine. But for people who are wanting to create new things, completely new, as the laser was completely new, say, then the current method does not work.
So what do you tell people who do want to do something? So what do you tell people who do want to do something completely new, who are in the current system?
Well, I don't want to tell them anything. You know, I would want to talk to them. I would want to talk to them and see what they want to do, but I've got no money now, you see. I cannot really entertain talking to people unless I can also support them. So unless you're at UCL, you know, I can't talk to you. You can't talk to somebody without just as a just for the fun of it.
It makes this event all the more special because you are talking to us.
Oh, well, I'm talking to you because you want to talk to me. And I'm delighted to be able to respond.
this was certainly a recurring theme during our book club, that our intention with it was not simply to read the book, but to decide what sort of action we could really take. And Don, as you've had experience taking action, and so we're hoping to learn from you, which is why we asked to speak to you.
Well, you know, you're talking to the wrong guy, because I've been 30 years trying to convince people that they should do this, and I've completely failed, I'm afraid. I've only converted University College London in my way of thinking, and all the other universities and all the other institutions have completely ignored what I've done. So it's rather sad, really.
Well, perhaps the answer there is to build new institutions. Jason, I think that's a good time to pass your hand.
Yeah, so when I think about the world of for-profit investing, you know, one thing about that world is that there is a feedback loop among the investors themselves. Successful investors get more money to invest with. Unsuccessful investors, you know, don't. Is there any possible way that a feedback loop like that could be set up for science, for those who fund science? Like, how could you even measure or score funders of science such that there was any kind of feedback loop to improve them, or to even find out who the good ones were?
Well, we've demonstrated that exists. You know, I backed there were 26 groups that I mentioned in the book, and 14 of those, at least 14 of those, have scored major breakthroughs. Many of them have won major honors, you know, nothing to do with me. They've been members elected to the National Academies of Science, the Royal Society, the Fellowship of Engineering. They've been knighted. Quite a few of them have been knighted. Quite a few of them have won major prizes, including the Fetlesson Prize, which is the Nobel Prize in Geology, which Steve Sparks won. So this is a very tangible way of looking at what we did. What we did not have any profit motive in it whatsoever when we initially backed them, but since then, their work, the value of venture research, as I've estimated in the book, is at least $1 billion, and that's for a $40 million outlay. So that is a method of assessing the value of what we do, but it all depends on people identifying greenfield sites that no one has ever, that no eyeball has ever ventured into, as what somebody once said to me.
So I think we have time for one more question. Mishka, I see you haven't asked a question yet, so we'll pass to you, and then we might wrap it up with some closing thoughts.
All right. Hi. Thank you, Don. It was a wonderful book. I really enjoyed it. Basically, when I was reading this book, because obviously, and like everybody else, I was reading it in the time of the pandemic. And so obviously, I was thinking in terms of COVID and how recent times, all the grants and all the funding is towards finding a vaccine, and then the review process is at its fastest right now, like, you know, the way the vaccine was approved and research was approved, like, so it was definitely, I felt like science is moving at a faster pace. But when I was reading a book as well, I realized that you mentioned Planck successors, or like, you know, investing in ideas which could be completely wild, or like, you know, you don't even know what you're going to discover, right? And so I'm kind of wondering, like, this new world we're in right now, where, you know, we've got like this, whether we're making such fast progress in like COVID related research, is this a step forward or a step back for scientific freedom, in your opinion?
Is a step forward? I mean, how?
Or a step back?
So I'm not understood the question. You know, does backing a scientist's idea of that he has identified a green, or she has identified a greenfield site, you know, a greenfield that no one has ever explored? I mean, how can that be other than great?
No, I was just saying that in light of COVID research, it seemed more towards a specific objective, and the objective was get a vaccine or protect. And so I felt like other ideas, those crazy ideas, were not being funded the same way. So I was just wondering, like, in one way, reviews is at its funding is at its highest, review process is at its quickest, but the ideas aren't those crazy wild Planck successor ideas. I was just wondering, like, where are we with scientific freedom now?
Well, we're nowhere at all. But it takes, you know, it took maybe 20, 30, 40, 50 years before Einstein's work was profitable in the current jargon, and even say Steve Davis's work, you know, took at least 10 years before it was very valuable. I mean, he sold his idea for £316 million. That's a hell of a lot. You know, that's a million times what we gave him. Sorry, 1,000 times what we gave him. So the venture research will be profitable one day, but we don't know when, and we don't know where it will apply.
Thank you very much, Don. And I think that's a really good spot for us to call it for today. Thank you, everybody, for attending. Sorry about our late start, but I think this has been really great. It's been a fantastic capstone to our book club. And yeah, just thank you, everyone. And thank you, especially Don, for taking the time to speak with us. I'll certainly be following up with some more writing and thoughts in this direction, and I hope each of you will too. And as usual, I'd like to end our book clubs with the same reminder that each of us lives in our particular corner of history, and we all have the capacity and often the obligation to be the people who make that change. And so if our aim is to create more scientific freedom, then we must be the people to do it. All right. Thank you, everyone, and have a good afternoon, evening.
Thank you.
I would like to thank you. You've got a group of intensely interesting young people. All of you are under 40, I would guess, it's an inspiration to people like me, because you are the people, you know, that I am committed to and devoted to and determined to succeed. Whether I will or not, of course, is another matter. Thank you.
Thank you very much. Thank you, everybody.
Thank you.
This has been fantastic. Thank you, guys. I will share the video very shortly once it's uploaded. And I will send it to you as well, Don. Thank you. Thank you so much. Take care. Have a lovely rest of the day or evening. Bye-bye,
everyone.
Thank you.